Engineering 305, that's kind of funny. Engineering 305, problem 317. This is actually a challenging one, not for really any reason other than I think it's hard to kind of grasp the angles and what they're asking for in order to get the right answers. And so we have to think through this problem a little more carefully. But what I like about it is if you follow the process, which is normally the case, you follow the process, just stick with it. It makes sense. And so let's get at it. 317, the thin rectangular plate shown in figure 317 is uniformly deformed such that the strain in the x direction. So what am I going to do? I'm going to start writing these things down. So let's see, I'm going to write them over here. Oh, I got the wrong pen though. It's the fun pen, and it's the wrong pen. It's the strain in the x direction is equal to 880 plus positive 880 micro. Strain in the y direction is equal to 960. That's also positive. See how I got to change the lens on my glasses? Yeah, it's not real good. And gamma is equal to negative 750 micro. Okay. Determine the normal strain along the diagonal AC of the plate and the normal strain along the diagonal BD. Hold on, I'm going to cut and paste this into my. No, I'm not. I'm just going to work with it. So let's figure out this normal strain. Let's hide this problem statement. Except there's a one thing we'll go back and forth on, and actually I'm going to draw it underneath the problem statement. Is I've got my rectangle, and actually, okay, so I'm going to redraw it. Look at the dimensions on it. It's 2 inch by 4 inch, and then I'm looking along these two lines on the diagonal. I gotta put my notation in there. A, B, C, D. And what I'm asking for is first I'm trying to find the AC strain in that direction, and then second the BD strain. Oh my goodness. The BD strain. I don't know why that's going. I guess I'm hitting it at two spots at once. BD strain. All right. So if I hide the problem statement, then I have everything I need, I think. What I really need, though, if I'm going to do a strain transformation, same as if I'm doing stress transformation, the next thing I want is what's theta. And there's two thetas. There's this one. This is, I'm going to say that's theta 1 and that's theta 2. But I've got my structure, I've got my shape. So if I go to the AC line, that's going to look like this. Right? And then this is my normal. But that's not the direction that they want the strain. They want the strain in that direction. They want the strain in that direction. Well, do I know what that direction is? Yeah, that's, sorry, one more time. Well, I'll do it again yet. That direction, T, well, if I look at the dimensions, that's 2, and that's 4. So this angle from here to here, theta 1, tangent of theta 1 is equal to 2 divided by 4, or I can punch that in on a calculator. Theta 1 is equal to 26.5 degrees, right? Theta 1 equal to 26.5 degrees. And so now I can plug that in. I can plug that in here. It's no longer a question mark. That's 26.5, and I'll say that's theta 1. Now I can do a transformation if I only knew my transformation equation. Where would those, oh, look at that. So there's my transformation equation. The strain in the n direction is equal to the strain in the x direction times cosine squared theta plus the strain in the y direction, sine squared theta, plus gamma xy sine theta cosine theta. That might have gotten a little long. See it coming out the ends? There it is. I have to drag it back a little. And now I can plug in with that 26.5 degrees, and what I'm going to get is theta in the n direction. And I call it n, but maybe I should say 26.5 degrees is equal to 596 micro. There's answer 1. Now, if I want to go in the other direction, I'm going to pop back to the top. I'm going to go up here in red and say, look, now I'm drawing, now my triangle looks like this. Right? And that's my normal. Oh, that's the same triangle. That's silly me. I'm looking at that. That is the equivalent of this. Yeah, that's not what we're looking for. We're looking for, no, that's not what we're looking for. I gotta draw this. Oh, except it's not that. Wow, struggling. That's my normal. That's my tangential, and they're looking along that tangent face, right? They're looking along that tangent face. Well, honestly, if I would say it's going in that direction, then this is still 4 and this is 2, but now my theta 2. Yeah, you know what? I'm going to just rewrite it here. My theta 2 is equal to a minus 26.5. All right. And if I take that and punch that in, I'm going to get the strain in the minus 26.5 direction is equal to, man, I'm just struggling with the screen today. 1196 micro. Wonder if I can get a glove, if that would help. Of course, I don't really want to wear gloves while I'm doing this. All right. I'd ask you if you have any questions, but, halfway through the semester, I kind of figure out that's pointless now. So do well.